Hey, hello everybody. Welcome back to the PBIC webinar series. We're glad you're able to join us for today's session. The webinar today is going to focus on a very important topic, lighting. Often overlooked as a strategy for improving safety, roadway lighting provides numerous benefits for visibility and conspicuity, as well as personal comfort and security. Today's panelists are going to discuss the importance of lighting, showcase some example lighting projects in San Francisco and in Seattle, and offer their thoughts on emerging lighting technologies and what the future of transportation might hold with respect to lighting. My name is Dan Jeline, and I will be facilitating the webinar today. Joining us today to shed light on this topic, sorry, no pun intended, are Frank Markowitz, James Lee, and Ron Gibbons. I'd like to go ahead and introduce them, each of them to you right now. Frank Markowitz is a principal transportation planner for the San Francisco Municipal Transportation Agency. He has over 30 years of experience in transportation planning for public agencies and consulting firms. His pedestrian safety experience includes managing the San Francisco portion of a federally funded multi-city study of innovative pedestrian safety measures. He also served 6 years on his local county bicycle and pedestrian advisory committee. James Lee is also with us today. He is a senior civil engineer working on the project development division with the Seattle Department of Transportation. Combined with both public and private sector experience, he has over 13 years of lighting experience. He currently leads the implementation of Vision Zero corridor and spot safety improvements. Ron Gibbons is also with us today. Ron is the director of the Center for Infrastructure-Based Safety Systems at the Virginia Tech Transportation Institute. He's also the Institute's lead lighting research scientist and is currently the PI of projects investigating the impact of outdoor lighting on human health, the spectral effects of new light sources on roadways, the visibility of police vehicles, and is the subject matter lead for the FHWA Office of Safety IDIQ contract. Ron is the author of over 80 published papers on roadway lighting, photometry, and target visibility. He's past director of Division 4 of the International Commission on Illumination and past president of the Illuminating Engineering Society of North America. We are grateful to have all of these panelists here with us today, and I want to get right into their presentations as soon as I cover a few housekeeping items. For those of you who may be new to PBIC webinars, I'd like to let you know that as attendees on the webinar, you won't have the ability to speak, though you will have the ability to send in questions and comments using the questions pod in the GoToWebinar control panel that you see there. You can send those in at any time. I'll try to respond to them as I'm able to, and we've actually held aside about 25 minutes at the end of the presentation today to facilitate a Q&A session with our presenters. We are going to be recording this webinar and are right now. We've also posted as an archive a PDF copy of all of the slides that will be shared today. Those can be accessed right now, or the slides rather, can be accessed right now at pedbikeinfo.org/webinars. If you follow to this webinar page, you'll see them posted there. I'll send out a link shortly as well, so you have them right in your GoToWebinar control panel. The webinar recording should be posted by tomorrow morning. Later today, you're going to be getting an email with all this information, a link to the webinar page, a link to the archived materials, as well as a link that you can use to generate a certificate of attendance for the webinar. So it's important to know if you're attending with multiple attendees at your site, please share that link with others so that they can also generate that certificate of attendance. We've also submitted the webinar to be considered for 1.5 CM credits to the American Planning Association. So if you're used to claiming those credits, I'd encourage you to go visit their event calendar and event page and claim them there on their website. We've got a lot of webinars we're doing this month, a few more coming up that I'll tell you about in a moment. If you want to keep track of all of our webinars, you can visit pedbikeinfo.org/webinars. You can use our social media networks to follow us there. We're actually talking about this webinar today using hashtag PBICwebinar if you'd like to follow along. Or you can sign up for our mailing list, all good ways to keep up with the sessions that we have happening. We have 3 more coming up between now and the end of the month. I wanted to tell you a little bit more about. Next week, we're continuing a series that we've been doing on common crash types between pedestrians, bicyclists, and motor vehicles. We'll talk specifically about preventing left turn crashes involving pedestrians next Thursday afternoon with a panel there. We have a webinar coming up later this month sponsored by the FHWA STEP program, talking all about rectangular rapid flashing beacons. That one's on October 30th. And then on October 31st, just the next day, there's a new resource coming out from FHWA on strategies for accelerating multimodal project delivery and how we can speed up the delivery of these projects that we want to see happen. So come talk with us then October 31st about that resource and some strategies that we've identified from agencies around the country. I'll pause here because what I want to do are a couple of things. First, I'll take a poll of the audience. We're interested in finding out a little bit more about how many people are out there today. So if you wouldn't mind just taking a moment and offering your thoughts on this poll. Is it just you attending the webinar? Have you got a few friends with you, a larger group? Please let us know about how many people are out there. And we won't spend too much time, maybe 20 more seconds or so with this poll open, and then we'll move right into our presentations. And while you're voting, let me just remind you again, we will be providing a link to the archive page, webinar slides, just as soon as we move into our first presentation. Just keep an eye on your screen and that link will come around to you. You can refer back to anything we covered today and share it with others if you like. I think most people have voted, so I'm going to go ahead and close the poll. I really do appreciate everybody's feedback. We can get right into our presentations today. We're going to kick things off with Frank Markowitz from San Francisco. Frank is going to share some ideas about lighting and showcase some projects they're working on out there. So Frank, you should see the screen control come to you now. I'll let you know when I see your slides and we can go right ahead. Okay, Frank, you're all set. Thank you very much.
Okay, thanks, Dan. Lighting improvements are often overlooked by transportation planners and some engineers as a key part of street infrastructure affecting pedestrian safety and walkability. So I really appreciate being involved in addressing some of these issues. Despite major potential benefits, safety and other factors, this is a topic that needs more attention. Perhaps the lack of attention especially in the transportation planning field is perhaps due partly because in some cities like San Francisco, street lighting is handled by a different department than the city transportation department, which is what my agency, the SFMTA, is. So in my presentation, I'm going to give some general background, talking about benefits and potential costs or adverse impacts, what are some traditional and more innovative options for lighting affecting pedestrian safety and walkability. I will go into some case studies, first a Las Vegas project that I was peripherally involved in, and then discuss some of San Francisco's experiences. Our other two panelists will give more of research and implementation experience that will expand my remarks. So looking at the research on the benefits of lighting for pedestrians, there certainly are major potential benefits, but interpreting the research is not as simple as it may seem. Fewer people walk at night. Clearly, the risk is much greater for illness, for injury and fatality for each pedestrian. And of course, reduced visibility is a critical factor. But other factors besides lighting can play a part, such as higher alcohol consumption by both pedestrians and drivers. And that makes it a little bit more difficult to determine what the impacts of lighting enhancements are. And similarly, if your improvements are system-wide, versus targeted to identified problem locations, that can also make a big difference. If you're targeting lighting enhancements to locations that are, say, very high in recent years in pedestrian injuries and fatalities, there is the potential problem of regression to the mean, that those locations were going to have reduced injuries from their peaks even if you did nothing. Similarly, there are some clear benefits for personal security and comfort related to crime, reduced tripping, and so on. But it can be a little difficult to assess how much of an impact on crime is due to the lighting. If you put lighting on enhancements on Street A, is it just moving crime to Street B? Is it the visibility improvements alone? Because increased perceptions of security may draw more people to the area, and that itself may discourage crime. I've also read a theory that improved lighting can give a message of a more orderly neighborhood, and that can even impact the daytime crime rate too. So if you're trying to assess nighttime versus daytime, and assuming it's lighting, that's further complicated. Regardless, transportation planners and engineers often find citizens telling us how much they value lighting enhancements for these security and comfort benefits. Sense of place. In some tourist areas, the light fixtures themselves contribute to identity of the area, increase vibrancy at night, historical values. This slide shows Vancouver's gas town. San Diego's gas lamp district is similar. In San Francisco, we have historic streetlights. On Market Street and Van Ness Avenue are two main downtown streets, and they have been the focus of some serious civic disputes when there's been any threat to their historic nature. Improvements in ambience applies not only to sidewalks, streets, but also often to civic plazas. For aesthetics and entertainment, light fixtures and lighting can interact with art, can even be the art. I think Vancouver, Canada, the Winter Olympic Village area of Southeast False Creek is some notable examples, or program light shows, and also a great variety of different types of lighting fixtures that are used in this area, make it much more interesting at night. Nearby city of San Jose, California, has had a program illuminating downtown that, for example, included reflective art to make freeway underpasses more inviting, interesting, comfortable to walk through, even changing the reflective light levels according to pedestrian and vehicle detection. Of course, there could be some concerns if this becomes distracting. There's also the potential of lighting to contribute to traveler information. San Francisco has had a concept seriously proposed, not yet fully funded or implemented, but pushed by a nonprofit to use lights above the surface of our main transit corridor street to show the subway below, so the subway trains moving, and also to project information on buildings about the subway movements. So those are a number of potential benefits. I wanted to point out that, of course, low light conditions are not just happening at night, that there is a significant amount of daytime in partial or complete darkness, depending on the time of year and the latitude, and thus the benefits of any lighting enhancements can be greater than if you were thinking of them just as applying at nighttime. I'm going to touch on some of the costs or potential concerns with lighting. First off, there's the financial cost. Lighting improvements can be very expensive. Municipal street lighting is typically a major part of a city government budget. Pedestrian scale lighting substantially increases the costs, and that can make a hard choice of deciding to invest in lighting versus other improvements, and in which locations. Other potential issues with enhanced lighting, besides the financial costs, you have glare, unwelcome light in travelers' eyes, causing disability or discomfort, unwelcome light raising safety, privacy, and comfort issues, and even astronomy and health issues. I think Ron Gibbons is going to speak more to that. So going over some of the main lighting options, first, traditionally, we have on the left the common street lighting, far more prevalent, focuses on providing illumination for drivers of the roadway, including the crosswalks. On the right, the pedestrian scale lighting is aimed primarily at sidewalks, walkways, crosswalk entries. In San Francisco, we pretty commonly have our visitor and commercial streets, like the waterfront Embarcadero shown here. They commonly have pedestrian scale lights. And on narrow streets, the lower pedestrian scale lights can also serve as roadway lighting. I haven't seen research on how much these pedestrian scale lights can improve safety on the wide arterial corridors. Now, looking at some more innovative options, I know Ron is going to speak to the light-emitting diodes or LEDs that are becoming increasingly a common form of lighting, so I'm not even going to touch on that. But one other option that looks promising, especially for isolated crosswalks, mid-block crosswalks, is Ballard lighting. It's been field tested in several locations. The idea is to illuminate pedestrians in the crosswalk, but not so much the background, to make them stand out. And this has found by RPI, Rensselaer Polytechnic Institute, a leading university lighting research center, has found pretty positive impacts overall on the pedestrian visibility using this Ballard lighting. Some concerns on glare for the drivers. However, in Schenectady, when they surveyed the pedestrians about crossing in this type of crosswalk, they were quite positive on average, saying they agreed somewhere between quote unquote somewhat and completely agreed that they felt safe and secure and didn't experience glare or dark areas. Also, you can use, and they did, use pedestrian push buttons to increase the light levels when the pedestrian is actually crossing, and that can, of course, act as an alert to the drivers to pay more attention. Smart lighting, it's also called adaptive lighting, that's used for energy savings and safety, especially. I was involved in this multi-city federally funded pedestrian safety measures research project. San Francisco was interested in testing something like what Las Vegas actually did, that is shown here, to use supplemental or higher levels of mid-block crosswalk lighting when pedestrians were detected by microwave or infrared. And what the UNLV, Nevada, Las Vegas researchers found was a statistically significant increase in drivers yielding to pedestrians. So positive safety impacts. However, relatively high cost compared to some of the other measures like signs and striping and signal phasing changes, and therefore they judged to have overall fairly low cost effectiveness. A different form of smart lighting in a city with some historic background in lighting, I just thought is kind of interesting. That look at San Jose, California. On the left, you see this slide that shows how in 1881 San Jose erected a light tower well over 20 stories tall, intended to illuminate the whole downtown with 24,000 candle power. I mean, imagine today the talk about sky glow and light trespass, and it didn't work as well as intended, especially in the windstorm that took it down. Now, more recently, much more recently, San Jose has gone somewhat the opposite direction in trying to focus and limit the lighting through remote control technology and LEDs, while also maintaining its effectiveness. I know Ron was involved in the evaluation. Interesting that citizen input was very important, and they even asked the local astronomical observatory for input about sky glow concerns. And for San Francisco, I'll talk briefly about some of our policies and a couple of projects. First off, San Francisco uses a streetscape pedestrian guidebook or manual, award-winning Better Streets plan, which includes a number of policies on, for example, where you would put in pedestrian scale lighting. In addition, the city maintains a list of approved pedestrian scale lighting fixtures and has agreed to maintain them when they were installed through a city area or corridor upgrade project that is typically a transportation planning and design project. Frequently in our transportation planning projects, citizens express interest in enhanced lighting. there are institutional and other reasons why it can be difficult to provide high quality lighting through these projects. Interagency coordination is required, and it can be complicated, and mention other departments responsible for the lighting itself. And then problem may be the tree canopy blocking lighting, and then you're dealing with yet another department or bureau about the tree trimming. You're dealing with potentially other civic disputes or issues. We've found that citizens may complain about lighting at an intersection that meets the Illuminating Engineering Society IES standards, but it could still be challenging to drivers to detect visibility if there's poor contrast, other distracting lighting, poor background luminance. And finally, funding is another issue. For example, our transportation sales tax, the bread and butter funding source for a lot of transportation improvements here, generally doesn't support lighting enhancements. One project I was involved in that looked at various transportation measures to improve a major transit rail and bus hub at Balboa Park, and lighting needs were identified as very important. So the study identified the locations in red as priority locations for pedestrian scale lighting. People are transferring between subway, surface light rail, and buses, and passenger autos at those locations. And the pedestrian scale lights were installed pretty much as mapped, and they were installed about every 50 feet, and that supplemented the existing street lights that were spaced about every 100 feet. This concept turned out to be very successful, effective but unobtrusive lighting with good color rendition. And last project I'm going to mention is a transportation planning project, a lower income area near our downtown, in which pedestrian scale lighting was prioritized for those red blocks based on public transit service, safety, nighttime safety needs, and security needs. And I know James Lee is going to discuss Seattle's experience in prioritizing locations for pedestrian scale lighting. So to conclude, I think there's a lot of room for additional information provision aimed at transportation planners and engineers, perhaps a manual that supplements all the technical material and the research that's out there. And I am pleased to be a part of that. So that concludes my presentation, and I'll look forward to our discussion later.
Okay, wonderful. Thank you so much, Frank. I think that's a great collection of good lighting principles, and as well as some highlights from your neck of the woods. I think we'll kind of keep that theme, and we'll visit Seattle next and find out what's going on up there with respect to lighting projects. And we have James Lee, who will take over the screen shortly and share some of the experiences and different lighting projects that have been happening in Seattle, and sort of how they fit into the bigger picture of what's going on there. So James, I can see your screen, and please go right ahead whenever you're ready.
Perfect. Hi, everyone. My name is James Lee. I'm with the Seattle Department of Transportation, and I'm here with you guys today to talk about lighting projects in Seattle. So a little bit of overview. I'm going to give some background about Seattle and the program that I'm in. I'm going to talk about the lighting guidelines that we use for LED lighting. I'm going to go over some projects, and then Q&A is reserved at the very end of all these presentations.
Hi, James.
Yeah.
James, I hate to cut into you. I think we're only seeing half of your slide on the screen. I wonder if it's possible for you to escape and then go back into full screen mode and see if that might correct it.
Oh yeah, sorry about that.
I don't think it was your fault. Let's just try it one more time if we can. If you can go back into the presentation mode in the slide show. I'll let you know when I can see it properly. Oh, perfect. That solved it. Thank you. Sorry for interrupting.
Okay, no problem. Thanks for letting me know. Okay. So Seattle is growing. It's one of the fastest growing cities in the U.S. We have a population of about plus 700,000 people. And a lot of this can be attributed to the big major employers like Boeing, Microsoft, and Amazon that are in our city. And some of our trends, while traffic has been generally going down, but within the last few years, it's been going up a little bit. Transit ridership has been on an upward trend since 2004. Vision Zero is the program that I'm in. It's our plan to end traffic deaths and serious injuries by 2030. We do it through the several E's of safety, but the two E's I like to focus on is evaluation. It's when we see how well our projects are happening and we make changes to our design after the project has been implemented. So if we're doing a project, the community knows that we'll come back and we'll reevaluate it and we'll make changes later. Equity is when we put a little bit of equity lens into our Vision Zero enhancements through data-driven analysis. An example of this is when we have ethnic communities with low participation and we can't reach out to them as well with traditional methods of outreach like online surveys and public meetings. So we'll make a greater investment into in-person outreach with translators to get more feedback from those who live, and we'll be using improvements that we implement. Specific to Vision Zero, this is kind of how we're doing. The blue line is our population growth since 2006. And since we've been tracking our fatal and serious injury crashes, it's been on a downward trend. This is from our 2017 Vision Zero progress report. It's available online. Specific to pedestrian crashes, these typically happen in the fall and winter months with fatal crashes happening when we have less daylight and more hours of darkness. So you can see the black areas there in September, December, January, and March. And these crashes, they happen between 5 to 6 p.m. So this is crashes within the last 5 years, focused specifically on pedestrian crashes. So as you saw from the early graph with our population growth happening, we have a lot more people taking transit. With more people taking transit, that also means that more people are crossing the street and walking out during the nighttime hours when we have all these ped crashes. So I think this really this data shows how clearly important lighting is in meeting Seattle's Vision Zero goals. Our lighting guidelines are based on the CIE 115. The CIE provides recommended practices for designing lighting systems for motor and pedestrian traffic based on several parameters present in the roadway system, and it places weights to the roadway characteristics from -1 to 2. So when you go through all these criteria, you add up these weights and then you plug them into the chart below, and it'll tell you how much foot candles you should light the intersection or the roadway segment into. So I can go over these. Speed limits will generally place a higher speed. Generally, higher speed limits presents more risk for people walking or biking when struck by a vehicle. With the center turn lanes and medians or one-way streets, we have center turn lanes and medians can help block glare from oncoming vehicles from the opposite lane. Less lighting is needed. With bike facilities, generally, higher weighted values are assigned to where bicycle traffic is anticipated. With the pedestrian planned priority tier. I'll go into this a little bit later, but more lighting should be placed where we have a higher pedestrian classification. With a block length, shorter blocks mean more conflict areas due to increased intersection density, creating more interactions between people walking, biking, and driving. With the traffic volume based on an FHWA study, lighting levels should be increased on roadways with high average daily traffic volumes and reduced on roadways with low average daily traffic volumes, since light levels have an impact on reducing crash risk for roadways. And with the presence of curb parking, parked vehicles may create potential for pedestrians to cross mid-block to get to their vehicles. So all these create some kind of conflict that we factor into our illuminance criteria. With our pedestrian lighting prioritization, we focus on 5 criteria here. With pedestrian demand is based around land use and pedestrian generators. Socioeconomic analysis, we look at equity factors such as socioeconomic and health factors, such as car ownership, diabetes rates, and disability rates. With the street type, this is based on the street segment and how we intend to use it. With the gaps, lighting gaps, we have areas where we have no lighting. This could become a barrier for people who take the bus and need lighting for security between the bus stops and destinations. And with the crime deterrence, I can tell you one story. Back in 2009 in the city of Seattle, a police officer was killed. And when they were asking witnesses to identify the car that got away, the witnesses were describing the car as a gray colored car. But when in actuality, it was actually a light blue or sky blue car. And the reason that they couldn't identify this car very clearly was because it was parked under a yellow high pressure sodium light. So with our conversion to LEDs, the white light, we see all the colors. So it helps with the personal sense of security when you're a pedestrian walking. And it also helps with the police when they are asking witnesses to identify what this person was wearing, what they were driving, and how they're getting away. With our LED conversions, we converted all our high pressure sodium lights to LEDs. We started out with residential streets in 2010, and we just completed our conversions of the arterial street lights this year. We have a current relationship with the Seattle City Light, which is our lighting utility company. Our memorandum agreement with them is that we, the Seattle Department of Transportation, dictate the lighting levels for the roadway, and the utility company, Seattle City Light, they are responsible for installing, removing, or maintaining these lights. And with the community feedback, when we first did our installation of the LEDs, we were piloting these LEDs with 5,000 Kelvin color temperature range. We heard from people that with the 5,000 color temperature, it was almost the lighting felt very cold. So we experimented, and we eventually settled on 4,200 Kelvins, which is pretty standard across all the lighting fixtures that we use, Cobra heads, pedestrian lights, and this it's a lot warmer than the 5,000 Kelvin temperature range, and it's pretty close to the color temperature of moonlight. So that's what we settled on here in the city. With adaptive lighting, we are currently operating in our Belltown area of Seattle. This area has a lot of nightclubs, bars, a lot of nighttime activity. So our lighting level that we used for the adaptive lighting here was primarily based on traffic and security. With the lighting levels, we use about 80% lumen output from dusk to 1 a.m. and this is for traffic in that area. And after 1 a.m., this is when all the clubs and bars let people out. We increase that lumen output all the way to 100%. So this is only focused in one area. Some future considerations for adaptive lighting are we might take a look at traffic volumes and may change the lighting based on that, or maybe use some sensors and change the way how much lighting is used based on pedestrian activity. The last project I'll talk to you about is a bridge lighting project that we did over in Ballard. So Ballard's located on the northwest sector of Seattle. On the left-hand side of the screen is an aerial view of the bridge that we were trying to light underneath. The importance of this project was to provide a connection between existing routes on the Ballard Bridge to two rapid ride transit stops. So rapid ride is our bus program where we have buses running about 10 minutes or less frequency. We take an existing line and then we look at bus stop consolidations off-board fare payment systems to reduce travel times by 10 to 15%. There's a lot of people walking and crossing the street and are using this path here. The project goals of this was to improve the connections between the Burke-Gilman Trail. The Burke-Gilman Trail is right here. It's this orange path that extends all the way from the north city limits. If you can see my cursor, and it wraps all the way around. It's 27 miles long. And it connects people who are biking or walking along this path to these two rapid ride stops. We wanted to pave the walkway to make it smoother for bikes coming through this area. We want to provide some signage for bicyclists, and we also want to provide some lighting. There's currently no lighting along this trail, perhaps some ambient lighting from adjacent businesses and from the bridge. So in this next screen here, so you have some overhead lighting from the bridge, but it doesn't really make its way down. To the left-hand side of this is like a little bar, but it doesn't provide much lighting on this trail, so it's extremely dark at night. Some challenges that we have here is access to, we have our Seattle Department of Transportation, we have our own storage yard fenced off back here. There are some utilities in the area and also a narrow trail path, making it difficult to bring in heavy construction machinery. So if we need to install some head poles along this route, it would be really difficult to get a little foundation installed with ped pole and ped light. There are some drainage, some ponding issues, so that might play a role in if we were to do underground electrical system for the lighting. And since we have a deadline for this project, it's FTA funded, we need to construct this project quickly. So we need to find some off-the-shelf lighting type products. So in general, poles and light fixtures have long lead times of about 3 months, and we wanted to construct this lighting project well less than 3 months. For the installation, we found a linear LED product that includes extruded housing to make installation of this product easy. The extrusion housed all the cables, LED strips, and frosted lights for clean installation. So we not only used some kind of marine adhesive to glue this to the bridge, but we also doweled the extrusion housing so that it won't jiggle loose or fall off due to the vibrations of the bridge. And this is what it looks like at night. This met our lighting criteria for pedestrian and bike pathways. So our lighting criteria is 1 foot candle and a uniformity of about 4 or less. Our average is 1.11 foot candles, and our uniformity exceeds what we're trying to look for. So 2.78 uniformity, that means that the lighting is pretty uniform here. And we're not focused on one area where it's pretty uniform lighting throughout the whole trail. We also installed some flex posts, so this allows for maintenance vehicles trying to access this maintenance yard or going through this area pretty easily. These flex posts can be run down by any vehicle, and it also helps delineate bikes going through this area. And this is actually not the first time that we use this product. So for the Westlake bus shelter, we didn't use the extrusion housing, but we just adhesive linear LED product on existing bus stops. So we cleaned this bus stop up, we added some lighting. You can see here how well it uniformly lights this area for people who are just waiting at this bus stop, and provides extra personal and pedestrian safety. And then with this, I'll hand it over to Ron Gibbons.
Great. Thank you so much, James. Awesome presentation of some really cool projects that you showcased there. And then we'll get back into some of that with questions that you all are asking now, a few things that have come up that we'll get into in the discussion period. But what I'd like to do first is turn things over to our final panelist, Ron Gibbons, to hear what he has to say about some of the advanced and emerging lighting technologies, and then we'll have our final 25 minutes or so for discussion. So Ron, I'm going to be sending the screen your way now. I'll let you know when I can see your slides. Okay, great. Ron, you're all set. Thank you.
All right. Well, thank you. Thank you for the presentation from the first two presenters. Those are some interesting projects. I guess my job here is to talk a little bit about where our research is going on some of these pedestrian issues, pedestrian issues, and the lighting direction. And of course, everyone we're dealing with is the future is connected in smart cities and all these terms, and so we are heavily involved in those kind of research, and this is basically our definition of the smart city. It's mobility, society, quality of life, economy, government, and environment, and all of these sort of work together, the smart city and the balance that you can create through a smart city. Pedestrians are a key part of that, because the quality of life, the ability to walk from the bus stop safely and ties into both the quality of life and mobility, or be able to sit in a restaurant and enjoy an outdoor cafe or something like that is critical to us. So those are our areas of interest, and there's the components that we believe in how lighting comes into play in that infrastructure is adaptive lighting, which was already mentioned, and basically that's the dimming of lighting based on need. So if you're designing right now, pedestrian volume comes into play in your lighting choices, and as a result, the lighting level is chosen by the pedestrian volume. But in times in times when the pedestrian volume goes down, we can reduce the lighting, particularly on low-speed roads. So in Seattle, for example, they're actually increasing the lighting when the bars are letting out because of the people milling about and things like that. So we can make these choices based on data collection, safety improvements. These are all enabled by solid-state lighting, by LEDs. And then we also believe that lighting is an enabler of the smart city and the connected infrastructure. So you can imagine using your lighting system as a networking tool, as a way to gather information, and things like smart poles and those are coming into play. So that's sort of our direction and where we believe lighting is coming into play in these smart city approaches, and obviously providing lighting for pedestrians is a critical component of that. Some of the things that are limiting the application of LEDs right now, I say first though that LED lighting is the current direction. I don't know of anyone right now who's designing anything with traditional light fixtures. But the uncertainties that are coming in that are kind of impeding some of those things was the color of the light source, the impact on human health, which lighting level to use, and all those are coming into play. And then of course the negative effects, light pollution, electrical issues, fusing, all those things come into play as an impediment to LEDs. So our research is really focused on looking for just right in lighting. And what we are talking about there is looking at these, what I'm refer to as the 6 factors of lighting design. There are the six, we're trying to balance these things. So obviously roadway lighting, user safety, roadway user safety, so drivers, pedestrians, crash reduction, pedestrian safety, all those things come into play as one. Energy consumption is always a concern. Impact on health, public perception and acceptance. Are people comfortable in the space, and are they willing to use that? Impact on light pollution, impact on surrounding areas, flora and fauna. And so one of the things that we've talked about is the way to balance some of these things is really to start looking at adaptive lighting. And so our approach now, which lighting designers are beginning to talk about, is to consider light as a drug. And with every drug, there's a benefit and a side effect. So if we provide lighting that can make a pedestrian feel more safe, but it is changing bat migration, we have to balance those two things. And so we have to determine the appropriate dose that will provide all the benefits and minimize the negatives. And the nice thing about lighting is it's what we call a rise and plateau kind of response. So if you start with no lighting and you add lighting, you get a change, and that as you add more lighting, the impact of that lighting will rise, and then at some point you get to a critical value where you've got enough lighting, and adding more lighting won't help anymore. So that rise and plateau. So we want to make sure we're not way out on the plateau. We're kind of at the shoulder where it changes from the rise to the plateau. And so those are the things that we're looking at with this light as a drug consideration. So the positive effects of lighting, obviously lighting is linked to safety. There's some models out there, one called relative visual performance and one called cumulative probability. And there's some older ones as well. The problem with most of these is they're correlative rather than causative. And what that means is that, you know, we change this value and we see a response, but there's no direct link between the two. And it just kind of happens. One of the problems is the lighting is generally a secondary effect. So if you've got a car crash, nobody says, oh yeah, I crashed the car because the lighting was really bad. There's no police report that will say that. They'll refer to run off the road, things like that. But lighting is never really considered as a primary cause. So we look at visibility and how all of these light fixtures come into play. And we'll start first with color temperature. So this was actually the study we did in Seattle and Ballard. And we did a detection test with people in a car, and we were looking at these three different light fixtures. And so this one's a little bit of a confusing graph. The 250 watt and the 400 watt are here and here. Those are high pressure sodium. Then there's a 350 or 3500, a 4100, and a 5000. And we did this detection test. We had people driving. They were looking at little objects sitting on the side of the road, and 4100 came out as the highest performance. And so we actually, this is the same data. I just removed some of the dimming and some of the other things that came into play. But you can see the comparison of a 400 watt high pressure sodium to the other light fixtures, the whiter light fixtures, and with 4100K coming out. What we believe is happening here is the addition of color contrast. So in high pressure sodium world or a low pressure sodium world, color doesn't really come into play. We already heard the example of the gray car. And so now if we start adding color to the world where reds look like reds and blues look like blues, we're starting to have an additional benefit through that, and that's one of the benefits of the light sources. So this is another one. This is the San Jose study where we looked at again a similar thing. We had a small object on the side of the road, several of them under different light fixtures, driving a car, and the current technologies is over on the right-hand side here, the low-pressure sodium. And we found that when we changed to LED, we reduced the watts per linear foot by 50%, but we actually increased the detection by 10 meters. And so then we said, well, what happens if we dim? So we actually reduced the lighting level to 50%, and the dim under the high pressure, under the LED, dropped down to the same levels there was under the low pressure sodium at the beginning, but we then took another 50% off the energy uses. So now we're at a quarter of the energy consumption with this installation, but have the same detection. So that's those are the kind of numbers we're seeing when we start adding in these white light sources and the king. And again, this 4,000, 5,000, in this case 4,000 popped out as being the highest performance, again because we believe of the color contrast. So the negative impacts of roadway lighting. So we've got this positive benefit of roadway lighting, and have started to look at CCT. Now the negative impacts, obviously health effects, sky glow, and what we refer to as the bugs, buds, bears, and bass. Buds being flowers, not beer. But anyway, so one of the things that happens is as we start adding lighting into the environment, we're impacting anything with eyes. So sea turtles, migratory animals, all those things. And for example, a robin, the bird, if it's in an area, if it nests in an area that's close to a light fixture, it actually starts singing much earlier in the morning. So it can sing up to 2 hours earlier in an area that's close to a lighted roadway. So these are all things we need to concern. The AMA came out with a report that says use 3000K. They did not consider the driver safety. They did not consider the crash risk, visibility. All they talked about was primarily the impact on humans, migratory animals, sea turtles, and sky glow. So they didn't talk about these other issues. So it's not really a balanced report, and so we're doing some work right now to deal with that. But basically, there is a strong link between lighting and health, and so this is particularly for shift workers. It impacts your sleep, your alertness, your general health, and your melatonin levels. And so, you know, your cell phone, your TV, they're all producing a lot more blue light. We're experiencing a lot more blue light than we used to. And our highest sensitivity, we're sensitive to all light, but where our highest sensitivity is in the blue range. So it's highly dependent on dosage. This impact, and so it depends on the spectral effect and the amount of light you're experiencing and the timing of that light. So there's some studies that went on and said, you know, we'll look at this, and we've got a major one going on at our facility right now. Again, a lot of them where they've looked at sky glow and things, you've got to make sure that you're looking not at a correlative but a causative kind of thing. So this graph over here on the right, the orange and blue lines are the point where your melatonin is being impacted. So melatonin is a hormone that drives your circadian rhythms, drives your sleep cycle, and at night your melatonin will rise and will allow you to put to sleep. So there is a rise in melatonin, and what these curves represent is the suppression of that rise. So it's how much our melatonin is not rising because we're under the light. And so the interesting thing here is that a bedside lamp or your phone or your tablet are impacting you by far more than the typical roadway lighting levels. And in particular, light trespass, just stray light coming in the window. So these are all things that we need to consider when we're reviewing these AMA reports. It's probably the lighting levels we're talking about are much lower than what we would experience for humans anyway. But sky glow is a problem as we move to these LED fixtures. The reason being is the sky is blue because of a process called Rayleigh scattering. So blue light comes through, hits the molecules in the atmosphere and scatters, and blue scatters more than the other colors. So the sky's blue. So now if you think about what the color of the sky is at night, the sky at night is still blue. So as we're sending light up that has some blue component in it, it will Rayleigh scatter. And so we have a higher component of scattering and sky glow due to a light fixture that has a blue in it than you do out of a fixture that has no blue. So we've got here, this is just an example. This is an old graph. I don't have any LED on it, but metal halide, high pressure sodium and low pressure sodium. The amount of sky glow, obviously the metal halide has a lot of blue in it and scatters more than what our traditional high pressure sodium is. The other thing we've got here is impact on flora and fauna. I already talked about the birds a little bit. This is a soybean field, for example, and we've looked at the amount of light that comes into the soybean field. The whole area to the right of this is a soybean field that's ready to be harvested. Soybeans are kind of interesting. When the night starts getting longer, that triggers the plant to flower, create beans, and all the energy from the plant goes into the creation of that bean. And so basically the plant consumes all of its energy and kills itself to create the bean. So under areas where the light fixture is, that transition doesn't happen, the flowering doesn't happen, the plant keeps growing. So you find that the plants grow very tall, but produce very few beans. And so we looked at that, and we can see here we've actually looked at lighting level versus yield, which is the lower value, and we've got moisture and things in the upper. So you can see that as we've gotten past 2 or 3 horizontal lux, we're starting to impact the yield from the field, and we're starting to impact how the plants are behaving. So our solution approach is adaptive lighting, and basically the goal there is to get as much lighting out of the atmosphere as we can, and to only use the amount of lighting that we need. So obviously it requires dimming. Traffic volume, weather, pedestrian usage, lighting conditions, these all come into play. And we've developed a luminance selection methodology that is documented in an FHWA document from 2014, which talks about this. But basically what it does is if we dim, we get additional energy savings between 20 and 40%, but it reduces maintenance costs, reduces interruptions to maintenance, overlighting, light trespass, sky glow. All these negatives that we're talking about are actually reduced by dimming and really controlling our light system to be what it needs to do. So it's only providing the amount of light we need. And so some of the criteria here are speed, traffic volume, medians, the presence of a median. If you've got a median that is wide enough so that a driver doesn't get glare from an opposing driver, you can actually use less lighting. Intersection, interchange density, ambient luminance, guidance, again, pedestrians and bicycles, parked vehicles. If somebody has a potential to step out from between a parked vehicle, if you need to sort of see their faces and what they're doing as it comes into play. And some of these are counterintuitive. We have evidence now that if you look at level of service on a roadway, an A, B, and a bit of a C level of service, lighting can come into play. Certainly in a C and D, there's benefits of lighting for crashes, but once we get into levels of services E and F, actually adding more lighting doesn't do anything, and there's a potential that we can actually turn the lighting off because of the sort of the approach that if the car in front of you doesn't hit something, you're not going to hit something. So those are some of the things that can come into play here with adaptive lighting, and we're still working some of those things out. Issues for pedestrians, light outside the roadway. We've typically on a high pressure sodium lamp, we've had terrible optics, and so the optics are have just automatically scattered light outside of the roadway onto the sidewalks, and we've never really specified how much light we need to put on a sidewalk. But LEDs have the ability to really limit how much light comes out of the roadway. And so actually now we're looking at having to develop a criteria for lighting outside of the roadway, just not the roadway, to provide visibility for pedestrians and to provide visibility for a deer running through the woods and some of those things. Not that the deer needs the visibility, but you as a driver need to be able to see that deer. So those are some of the things we're doing. Light source selection, we want to choose a color temperature that maximizes visibility but minimizes some of the other issues, and illuminance. Vertical illuminance is where we're going with the criteria. And so what that means is we're looking at how much light falls on the surface of the person, not just how much light falls on the roadway. So that Ballard design that was shown, it's great at illuminating the person because there's lots of vertical light in there. The problem with vertical light is it also shines in drivers' eyes, and so the Ballard highlights the crosswalk, but but doesn't actually necessarily create visibility. So the these are the things that we're starting to work with. So this is the traditional, the impact on lighting design for a pedestrian would be to move that luminaire from right over the top of the crosswalk and put it so that the luminaire is actually lighting the front face of the pedestrian rather than the top of their head. The same goes with intersections where we're pulling the traditional design from a luminaire on a pole out of the intersection into the space. This one, there's actually 2 research efforts going on right now, one in Virginia and one in Illinois, where we're looking at that because the intersection right now is lit to a brighter level than the roadways, and so there's some issues with contrast and if we making sure that we're lighting the pedestrian. The other problem we've got is making sure that the pedestrian on the far side of the intersection is as well lit as the person on the approach side of the intersection, and so that research is ongoing at this point. But if we start thinking about the future, obviously connected vehicles, connected pedestrians, all of these things, if you start thinking about where we can go with a connected and a smart system, we are now talking about things like lighting on demand and being able to turn on the lights as required for a pedestrian. They've got an app on their phone that turns on the street light kind of idea. So if you start thinking about this, again, this is the concept of lighting as the network and as the backbone. So you can start looking at using the lighting system to communicate things from your ITS network. Your signal phase and timing can all be communicated across a network. That includes the lighting, and you can have the lighting react to the presence of those things. Loops in the road can come up, and this we believe the street lighting can actually become the city's central nervous system. So a little bit, and hopefully this plays, this is a system that we've developed here, the lighting on demand system. The video is a little funky, but what's happening here is the vehicle's got a DSRC communicator, and our roadside equipment is picking up the signal from the car coming down the road, the basic safety message from the vehicle, and as it drives along, our system then calculates which luminaires need to be turned on, turns on the luminaires, and then turns them off when the vehicle passes. So we did some work and looked at visibility and whether we could actually control the driver's speed if we don't give them as much space in front of them, and there are as much visibility in front of them will actually slow down. Unfortunately, they do not, and we need a little bit of light behind them. But now, if you imagine we've got a pedestrian out there with a phone and having the lighting will actually highlight the presence of the pedestrian and some of those things. So long-range future for us, more autonomous vehicles, and we're going to start hearing about rumors about we don't need lighting because the vision systems on the vehicles will do everything we need it to do. But in particular for this study or this discussion is pedestrians will always have legacy vision systems. So you've always got eyeballs that are coming into play. So there's always going to be some sort of a form for lighting so a person can walk safely and those sorts of issues. But that's really where we're going and seeing lighting happening and how it plays into the pedestrian lighting issues. So I think that's all I had. I guess I'll turn it back to Dan.
Yeah, that's great, and I'll actually just take it right from you. Give me a moment. I'll set up our slide, my slide here that I have that I'd like to get into on our Q&A. So hopefully what you all see now is some contact information for our panelists, just in case you want to reach out to anyone with specific questions. Feel free to do that. I think we saw a huge range of topics covered today, not only sort of what the lighting principles are that we may be used to and some different strategies, all the way to some of this more recent, these advances and what we might see in the future. I wanted to get back. We've got a lot of questions that came in, and I want to get to as many of them as possible. You all talked, I think, to some degree about light pollution and this idea that we want to have enough lighting, but maybe not so much that we can't meet our other goals. And so I'm wondering, a lot of folks that send in comments, they've been advocating for more lighting, but they might run into obstacles or barriers or people pushing back saying, well, light pollution is a concern, so we can't do lighting projects. And Ron, you made a really interesting point about lighting being sort of like a drug. You don't want way too much of it, but you also need plenty to accomplish what you want to do. And so I'd be curious to hear your perspective on how a person in a city might approach that conversation with a decision maker or someone who's kind of claiming light pollution as the reason we can't do more lighting. And I'd also be interested to hear if Frank or if James have experiences kind of hearing some of these arguments and trying to find middle ground with decision makers about what sorts of lighting levels do we need to be prioritizing. So Ron, I wonder if you could take a crack at that first.
Yeah, that's an interesting point. Again, it comes to a balance. You can choose a luminaire that that minimizes sky glow, and what the interesting thing is, most sky glow comes from low angle light. So what that is light that's coming up above horizon at about 10 to 20 degrees, so 0 to 20 degrees, kind of that. The light in that sort of cone, first of all, the light's traveling through the atmosphere more, so it's got a greater distance to travel, and there's a lot greater chance of it causing sky glow. But where light that comes off of pavement surfaces and light that's directed goes straight up, it's not great. It's not a good solution, but it actually causes less than the stuff coming out at low angles. So you want to make sure your luminaire is chosen such that there is no light above that horizon. In fact, if you really want to limit it, you really want no light above 80 degrees. So from 80 degrees from vertical, and so you're not sending as much light into the atmosphere on those low angles that can cause a lot of scatter. So someone's luminaire choice, and then most of it is making sure that you're not overlighting. There's been a trend forever of the belief that more lighting is always better, and so you've got a high crime neighborhood, you slap in a whole bunch of lighting, and the crime will go down, and then the crime comes back up, so you slap in more lighting, and it's really not helping much. But so there's those trends, and so selecting the right lighting level is what's important. So stick with an IES level. Don't go, okay, well, if one IES level is good, 3 times would be better. But it's really limiting that overlighting aspect of it. So it's luminaire choice and minimizing overlighting.
Okay. That's awesome. Thank you, Ron. And I wonder, James or Frank, I'm sure you've had conversations, where this has come up, and the goal is to find the right balance of lighting levels to still respect what you want to accomplish with light pollution and the various other stakeholders that are involved. Any tips for helping agencies and others on the call maybe navigate these conversations and find that middle ground?
Yeah, I can start off. So I think going in line with what Ron was saying, we typically try to limit the amount of lighting that we put in the roadway to the guidelines that we have in our criteria. So whenever we start our lighting analysis, we actually focus on the intersections first, because that's where all the conflict points are. That's where all our vulnerable modes are mixing in with all the cars and the buses. So we focus on that first, and we try to light it to a minimum, and then we'll take a look at the roadway segments afterwards. So then that's how we kind of prioritize it when we do our lighting analysis. Our lighting criteria also allows us to take a look and revisit back certain areas where we've lit before, and we start getting some complaints about light trespassing into people's properties. So what our utility company does is maybe they'll go out there and then they'll angle the light. They'll do a bit of house side shielding on the light to prevent some of that light trespassing. But whenever we have larger changes, such as road diets, rechannelizations, or even changing the posted speed limit, we'll go back and we'll revisit, and then sometimes we'll even lower the amount of light that the roads needed, because you don't have all that friction anymore. You have a little bit less friction in the roadway because of the roadway parameters.
Okay. Great, thanks very much for that. Frank, I got a different question to get to from San Francisco. Wondering if you can weigh in on this. I've got a lot of examples of, of questions that have come in and comments that it's been difficult sometimes for a person working in a city and working to maybe identify lighting improvements, but maybe the cities are not in control necessarily of making all the decisions related to lighting, and there's maybe a public utility or another organization that is making those decisions that can at times be difficult to coordinate with. Not always those groups are at the same table, and I wonder if you can offer any thoughts or ideas about how to maybe accomplish that better coordination between what you want to accomplish for safety and through Vision Zero and other activities, and then and bringing other partners on board who you may not have worked with closely previously.
Okay, Dan. Thanks. Yeah, that's challenging and remains a challenge in San Francisco. I think one key that we try to do is to work those interagency issues out before you get a specific project or controversy, and to try and come up with policies that you can agree on beforehand. And thus, in a lot of our pedestrian safety work and in the Better Streets plan that I mentioned, there was extensive work with half a dozen to a dozen different agencies. So we would talk with our public works department that is designing the lighting, and the Public Utilities Commission that is maintaining the lighting, and to try and have agreements beforehand, like PUC, the Public Utilities will maintain ped scale lights that are in their catalog, or at least go through some process of review before selection. So there still is work to do. I mean, we've been trying to work with the agencies, especially Public Utilities Commission, to try and get a quicker response and agreements for supporting lighting enhancements that come up through transportation planning projects. And so we've been working on that. I know it can be difficult to budget issues. Other issues may take priority, but as much as you can, getting those sort of agreements and policies in place first is helpful.
Yeah, well, that makes sense. And I wonder, along the same lines, I'm not sure. You mentioned the Better Streets plan that you all are working off of. I don't know if you have a lighting plan. I can't remember if you mentioned that or not. But I've even heard of some agencies developing lighting plans and then coordinating those not only with their local utilities, but also with things like street tree plans. So you aren't necessarily putting your lighting in places where trees are going to be growing into a canopy and blocking the light. Things like that. I mean, is that maybe another opportunity to do some of that coordination as early in the master planning phase for developing a roadmap for all your activities?
Yes, absolutely. And that is an area in which San Francisco could improve. We could look, say, to Seattle, as an example, where they have that lighting master plan for pedestrian scale lighting, or our neighbor to the south, San Jose, because we don't have the equivalent citywide lighting master plan, just some specific policies in this Better Streets plan that I mentioned.
Thank you for that. I wanted to turn things back to James. Actually, James, I got a couple of questions for you about how you do a few different things in Seattle. We got one question about how you change the lighting intensity. I think I'm getting this right. How do you change the intensity in your lighting? Do you use a time clock, or are you able to change things from a central office? Can you talk about logistics of how you accomplish that?
Yeah, so in one of my presentation slides, there's a little blue device in the Cobra head luminaire, and that controls the lighting. The current way that we do it right now is there's an app that we connect to it back into like I think an iPad in the office somewhere. So someone has that iPad, and you're able to kind of fix the lighting from there. So it's controlled through there, and then I think you get some daily monitoring reports. So you can tell if a lighting has failed, if it needs replacement. And I think that plays a big role when I have to go out into the field when there's a fatal or serious injury crash that happens, and then you have to report on what the conditions are happening out there. So I think those kind of monitoring tools help tells you if the light was actually on or not at that event.
Okay, very good, thank you. And then one other question. I think you mentioned that in Seattle you were implementing 80% illumination thresholds from dusk to 1 a.m. and there's a question about how you kind of went about making that decision. What was the impetus for that?
We took a few streets, and then we calculate what the lighting level was. So when I went through the several parameters that we went through, so traffic volumes definitely play a role. If it's more than 480 vehicles per lane per hour, then we weighted with a +1. But when traffic volumes drop to less than 240 vehicles per lane per hour, it's a -1. We look at the head density, and we look at we look at a few the ped density and the activity, and we worked with some of the businesses and the bars in the area. So we tried out a few different areas, and we found that 80% was the lighting level that was just enough so that when you raise it, the relative look of the lighting on the roadway was enough to signify importance in the lighting levels.
Great. Thank you for clarifying that. Ron, a question for you. There were quite a few questions coming in about lighting from vehicle headlights and standards, related to that, and a lot of speculation. I don't know that there's been research. Maybe you can shed light, but speculation that brighter vehicle headlights actually might create glare, either hiding pedestrians or either creating glare that might even cause crashes to happen. This is the speculation from several of our attendees, and I wonder if you can shed any light on that for us and share what might be known from research and the not the lighting coming from the street lights, but from the vehicles themselves.
Yeah, the headlighting is an interesting thing because the amount of light that you can actually put forward is limited by the SAE. So there's no more light coming forward, but it's coming out of a smaller spot. So when we used to have the big square steel beams, and then we went to the projector beams, and now we're moving to LED. So our impression of the lighting is that it's getting brighter. It's not really getting brighter, but it's getting smaller. So that gives us a higher glare impression, and so there is that issue happening. And so as we're dealing with this, the LEDs and all these other issues, as the headlamps get smaller, the luminance or the actual space that the lighting comes out of is smaller and causes more glare. So as a result, you end up really limiting really limiting some of the visibility. You get more twinkle and some of those things. And so some interesting things are starting to happen. There's an approach where you're actually going to notch out the beam. So if you can imagine that you're driving down the road, your car senses an approaching vehicle and will actually take out the part of the beam that is aimed at that approaching vehicle and just shut it off, so that you'll still have the light on the road in front of you, but you won't actually be sending any direct light at that vehicle as it approaches. And so that it'll notch. So there's a lot of work going on now to try and limit those kinds of impressions and things. There's an interesting aspect of headlighting too, and that's in how it mixes with overhead lighting. So the way we've traditionally, and I talked a little bit about contrast issues and problems at intersections. So the way the pedestrians have been is they've typically been lit in such a way where you've got a bright intersection and then you've got a dark pedestrian. So the pedestrian's actually seen in silhouette against a bright intersection. But as the vehicle comes along and the headlamps hit that pedestrian, it starts lighting up the pedestrian. And so there's a point where the pedestrian comes up, goes through so it has the same luminance, the same amount of light as the intersection. Then it comes out the top and is brighter than the intersection. But as it goes through that point where it has the same luminance, the pedestrian will actually disappear. And so there's work going on there that we're trying to sort of get around and really look at how all these things are integrated together. So, for example, whenever I run a study here at my facility, I always have vehicle headlamps on, and so we're always looking at that integration of those things. Okay. So I'm not sure if I quite answered the question, but that's sort of what things are happening.
No, I think that's a great response. It covered a lot of different issues there, and I think you got right to it. So thank you. A question for Frank and for James. This one gets to a topic we actually covered in a webinar last week. Some systemic safety improvements that agencies are moving toward, making improvements at a more at a risk-based level rather than kind of doing improvements at crash sites. They've done things where they know there's high risk of crashes that may not have happened yet. And there's a question about whether our lighting improvements can be done or should be done in more of a systemic or a risk-based way, where you might be looking at entire corridors that may be at risk of crashes, and a lighting improvement will help up and down the corridor. Or if an agency might find some success in looking at high crash intersections where they don't currently have lighting, and maybe using lighting as a way to respond to a safety issue at the intersection. So on one hand, we're talking about whether it can be done systemically and proactively based on risk. And the other hand is, should we be looking more at entire corridors when we think about lighting improvements, or can it be beneficial to focus and make sure we have all of our intersections very well lit and focus on intersection lighting? And I'd be curious to hear your responses to those. Maybe Frank, if you want to start that one.
Okay, Dan. Yeah, in San Francisco, there has been a move in recent years to not focus too much on isolated intersections that have high crash rating, especially in the last few years, and to look more at a corridor approach, looking at several blocks and looking at factors, risk factors that should be considered in prioritizing locations for investments, whether it's signal improvements or curb bulbs, or could be used for lighting, but to look at a range of factors, often a score like transit use nearby and pedestrian volume levels, the types of land use, speeds and volumes of vehicles, and so on. and to use such scores and still look at, and of course we pay attention to the high crash locations, but not to focus solely on isolated locations.
Okay, great, thank you. And James, anything to add to maybe the strategy in Seattle, the maybe corridor versus intersection approach and risk versus going to crash locations?
Yeah, so actually we do it in both at a spot level and at a corridor level. So with the spot level, we actually have access to Seattle Police reports, and we have it coded into our GIS database, so we can tell where the crash happened, at which corner it was happening, and time of day, and whether or not the streetlights are on or off. So using that, we can do a geospatial analysis to figure out where some of the spots are in Seattle where we have trends and or recent trends of nighttime crash locations. So we'll take a look at it specifically at that approach. And then also with the corridors, whenever we do a big corridor project, so a couple blocks to maybe a mile, half a mile to a mile long. If it goes through our capital projects program, so any project that's more than $100,000, we end up doing a lighting analysis for the whole corridor, and we work with Seattle City Light, our utility company, and they reimburse us for the cost for upgrading the lightings along the corridor. And for other corridors where we're just doing like maybe small spot treatments throughout the corridor, we would also do the lighting analysis, but it would probably be less intense. So we'll probably swap out some lower wattage collector arterial grade LEDs for some principal arterial grade LED lights. So we'll up the levels in some areas, and in some cases we primarily focus on the intersections and wherever we have ped crossings. So we'll enhance lighting for those areas, and then we may come to like an in-between medium ground with the roadway segments in between those conflict points.
Okay, great. Well, thank you so much for both of those responses, and I think you've provided a lot of inspiration to the folks on the line today. I'm sorry to say that we don't have any more time for questions. I do hope you'll follow up with our panelists if you'd like to talk more with them about these topics and get your questions answered. I want to remind everyone that an email will be coming later today with a link to our archive page, instructions for downloading your certificate of attendance. That's where you can find the meeting slides or the presentation slides from today, and tomorrow morning there will be a video recording for this session if you'd like to look back at anything. You'll also be greeted by a brief survey once you exit the webinar. We would really appreciate your feedback on the session today and maybe ideas for future webinars that we might be able to plan. We do have a few more coming up soon, so I hope you'll join us for those. And I just want to give a big thank you to all of our panelists for joining us today and providing their presentations. And thanks to all of you for attending today's PBIC webinar. I hope you have a wonderful day, and we will see you next time. Thank you.